Alright, so the more time that you waste, the less time that we have to review for El Pesto. Um, we'll get through as much of that as we can. If I will tell you that if you, having looked at the test, if you can understand everything that's on there, you should do perfectly fine tomorrow. Uh, just again, is there anybody that's not going to be here tomorrow that knows they're not going to be here tomorrow? Okay, we'll see. The first thing I wanted before we started this though, somebody, not in this class, but in a different class posted this online. So I might as well reward good behavior. So I'm just going to go over this with all my classes. This is from Khan Academy that's due tomorrow. You won't find anything this complicated if you want to call it that on the test, but doesn't mean you shouldn't know it. What operation are you being asked to do here? I'll write it bigger if you can't see it. Just 1 over. Wow, now I can't even see it. Let's see if I bring it over to the screen. That looks like a 5 over 4. So 1 over y to the 5/4. So again, what operation are we doing? It is division. Okay. And see, what we do here depends on what the instructions are. If the instructions said simply to simplify, then what I would be worried about is removing the radical from the denominator. I would worry about rationalizing the denominator. You might look at it and say, whoa, what are you talking about? I don't see a radical down there. Why is there a radical in the denominator? Why does that count as having a radical in the denominator? Yes, Maurice? The exponent is a fraction. Very good. Every exponent that is a fraction can be rewritten as a radical. The reason why I wouldn't worry about that now is because you do not know how to rationalize fourth roots. That's what that would become, as a fourth root. The denominator is a fourth. That would be a fourth root. You don't have to worry about that now. But this still does give you some practice with properties of exponents. The directions do not say to simplify. They say to write it in the form of a single base, which the base here is y, to a power. So my focus here would be to get rid of, or let me rephrase that. Let me not say get rid of, but to move the y out of the denominator, because I won't be able to write that. I mean, do you see when I say, or when they say y to the nth power, that's what they want this written as. Do you see a fraction there? No, you don't see the y underneath anything. When you don't see a fraction, that's considered to be in a numerator. So it kind of is counterintuitive to what we're used to, but what property of exponent allows you to move around the base from a numerator to a denominator and vice versa? There was one of the properties of exponents that focused on how you can move a base up or down, depending on what you do to its exponent. Study, study, study. Kayla, you know? Lorena? Well, very good. You change the sign. The reason why I say it's counterintuitive is because normally we want to make a negative exponent positive, but here we have a positive. So yes, one way you could do this is just get the y, move it up to the top. Now there will be nothing left on the bottom, just the 1, which means I don't need a denominator. Though this 1, so maybe it's better if I drew the arrow going here. Maybe that would make you less confused. because that 1 would stay in front of the y. When I have a 1 in front of a variable, I don't need it. And I would just be left with y to what power? Instead of 5 over 4, it would be negative 5 over 4. Which is weird because as far as simplifying goes, we don't want to leave a negative power. We don't want to leave a power that's a fraction, but that's what we're being asked to do. And any directions that are being explicitly given to us supersedes any rules of simplification. If we're being told to do something specifically, then we'll do it. The directions here didn't say to simplify. The only other way that I could explain this to you, if you don't understand that particular property, I could explain this to you using a different property. If you don't understand the whole thing about changing the sign of the exponent, is I can tell you, okay, you still have to understand that in order to get this that we have in red to look like what they want, y to the n, I have to get rid of the fraction, right? So we see on the bottom is a y to the 5 over 4. How many y's do you see on top? You see a y on top? No, I don't see any. So theoretically, this would be the same thing as saying y to the 0, 1 y to the 0. And by writing it, doesn't make sense to write it that way, but if you were to write it that way, now you could use a different property which says that if you're dividing the same base, what are you allowed to do to the exponents? If you're dividing the same base, what can you do to the exponents? Thank you, subtract. What would we be subtracting? 0 minus 5 over 4, which just like before still gives you negative 5 over 4. And that's what you would write. So I just explained to you how to do this 2 different ways. Any questions there? So now we'll get started with the study guide, but just let's call this on a hunch. I actually want to skip to the end first. I want to do 22 first. Not necessarily because there's going to be an abundance of these on the quiz, but I mean, really, for what we just saw on the last example, maybe because you have the least familiarity with it, like where not everybody's completely understanding properties of exponents, and that's what we would be using on 22 is properties of exponents. What operation are we doing? Division. So when you divide, you're supposed to divide any numbers in front, any constants or coefficients. What are the coefficients here? 2 and 4. So I have a, what is 2? 2 cannot be divided by 4, but it can be reduced. What does that reduce to? 1 over 2. The reason why I made the fraction bar somewhat big is so that I leave my space for my variables. Now, because the directions here do say to simplify, I'm not being told to leave it in any specific form. Okay? I do not want to leave negative exponents. It doesn't look like fractions are going to be a problem because I don't have any fraction exponents, but I don't want to leave any negatives. So I can teach this one of 2 ways. Okay? The more universal way, where if you just want to do the same thing every time, you should always subtract the top minus the bottom. Top exponent minus the bottom, kind of like we did here on the first one. That's if what you're searching for is I need to do the same thing every time, that you are allowed to do every single time. Here on this first one, I did 0 minus 5 over 4. You can always subtract top minus bottom. But also illustrated by this example is what could happen if you always subtract. Not always, like it won't always happen, but it could happen if you're always subtracting top minus bottom. What could you end up with? What type of numbers and sometimes come as a result of subtraction that we're trying to avoid. Negatives. So if what you're searching for is a way to always avoid negatives, I can teach you that also. I can teach you how to avoid negatives. You just have to, like, so long story short, you can do, like, for the y's, what y is on top? Like, what exponent is on top? A 1. So for the y's, 1 minus, it'd actually be minus -2. And if you do it that way, always top minus bottom, whatever you get is going to always start off at the top. Like the result, you'd always place it at the top. But be aware that you might end up with a negative, which needs to be fixed later. If you want, hey, you know what? Let's just do it both ways, here, let's do it that way. Ready? So for the y's, what is 1 minus -2? Positive 3. And since I'm following that rule, whatever I get, I put at the top. For the x's, what is -1 minus 3? -1 minus 3. If I take away 1 and then take away 3, -4. And because I'm doing it by that fashion, I put it at the top. For the z's, what is -1 minus -4? Blake, you look confused as to why I got a -4.
What?
You look, is it that you can't see or that you can't
tell?
No,
I'm not confused. I was the one who said it.
It's 3.
Oh, you just can't see them?
I can see.
Okay, all right. So z, -1 minus -4 is 3, good. But again, it has to go on the top. At least at first. Am I done?
No.
Why not?
You have a negative.
Good, I cannot leave a negative exponent. So the way I fix that is I drop it as if it was hot. Because I can tell that there's going to be some variables left in the numerator, I don't need a 1. So the 1, I'm not going to write it. But I will write the y to the third. I will write the z to the third. On the bottom, I still need the 2. The x drops, but instead of being to the -4, what do we get? Positive 4. And then we'd be done. MK, I see you thinking. Say something if you're stuck. Here's the other way I could teach you to do it. If you feel comfortable doing it that way, honestly, I used to teach it that way. When I first started teaching that I had Algebra I classes, I was searching for uniformity. I wanted the kids to do the same thing every single time. I wanted them to understand the concept of a negative exponent and how to fix it, how to simplify it. So I taught it that way. But then over the years, I kind of grew frustrated because not every kid would learn the rules, right? So I kind of gave in to, I don't know how to, convenience, I guess I could say. And if you want maybe a more convenient way of doing this, here's another way to think of this. Notice how I removed that first step. You still have to reduce the 2 and the 4. That doesn't change. What is 2 over 4 reduced to? 1 over 2. So if you still want to waste a step and put the 1 on top, you can. Just don't leave it there. I'm not typically a person to take away credit for that, but I can't speak for others. So, I might let it slide this year, but then you go to another teacher in Algebra 2 in a couple of years, and they mark you off for that. Instead of always doing top minus bottom, do big minus small. Look for the common variables, and then always subtract the bigger number minus the smallest number. What is that going to guarantee you? It's going to guarantee you always getting a positive. Anytime you subtract a greater number, a number that is to the right on a number line, minus a number on the left, you're always going to get a positive. You're always going to get a positive. Now, the twist would be, though, if you're going to do it that way, you need to leave the result wherever the bigger number was. So let's see if we can use that. In this case, let's go in alphabetical order. Let's just go X, Y, Z, right? So look at the X's. 3 and -1. Which number is greater? 3, right? So what is 3 minus negative 1? It's 4. It's positive 4. Where was the bigger exponent located? In the denominator, so I put the x to the 4 straight there. I put it straight there. I don't waste time in the numerator, I just put it straight there. Now let's move on to the y's. On the top is a y to the first. On the bottom is a y to the negative 2. Which number is greater? Which number is further to the right on the number line? A 1. What is 1 minus negative 2? 3. Where was the bigger y located? On the top, so the y to the third goes on the top. Okay, now for the z's, negative 1 and negative 4. Which number is greater? Negative 1. So what is negative 1 minus negative 4? Also positive 3, and because the greater number was in the numerator, the z to the third goes in the numerator, and you're done. So I've shown you 2 ways to do this. You pick whichever one you feel more comfortable with. Are there any questions on that one at all? Okay. The only other thing I see here that I would need to go over just in case I don't get to this is not even something really to go over. I just want to make, I picked up on this as I was reading through it. This is a typo. I don't want anybody to kill themselves over like, what is the product of the product? No, that's a typo. This is just say, what is the product of, like, so like scratch this stuff off. What is the product of 13 square root of 5x to the 5th? And actually, you know what? I just noticed something else here too. And I have a feeling that this was also a typo. Because if not, it kind of, just take my word for it. Let's pretend on this one that the radical extended above the x to the 5th, extended over, like, because it looks like that x to the 5th is not underneath the square root, but it should be. Because if it wasn't, they would have written it out in front to the left. If it would have been outside already. So we'll try to get to everything today, but just in case we don't. Any questions there? All right, so let's fly through the first page because the first page should be pretty quick. Here we're given an expression, a polynomial. Right, Chase? If you went ahead and read through the study guide already, and you already attended these, nowhere in these 4 questions that pertain to this polynomial does it ask you to write it in standard form. And now number 3 does say if it was in standard form, but they don't ask you to write it in standard form. I would advise you to do it anyways, just for fun. You never know what you're going to be asked to do on the test. So if I were to write this in standard form, what would come first? 4. The 4x to the 3rd power. If I were to write this in standard form, what would come next?
3x.
So make sure you write plus 3x squared. And if you were to write this in standard form, what would come last? Negative 7. Now let's answer the questions. How many terms are there? 3. Name the constant. Negative 7. If this was in standard form, which now it is, what would be the leading coefficient? Leading, not leading term, leading coefficient. 4. And if you were to get this wrong, that would be marked wrong. As a matter of fact, on the unless this changes also, one of the things that all the Algebra 1 teachers agreed upon for the test was that all or nothing. Like, there is not going to be partial credit. So, I would take that. If you were to write up here 4x to the 3rd, I would take that as to mean that you don't know what a coefficient is. It clearly says coefficient. Coefficient is just a number of terms. Right, Sinacho? Any questions on that one? Okay, the last one. Classify the polynomial based on the number of terms. I like that question. Make sure that you're paying attention there. Just trinomial. Whoa. But wouldn't that be a cubic trinomial? Yeah, you're right. That type of polynomial is absolutely a cubic trinomial, but that's not what you were being asked. That's why I like this. Make sure you know the difference between what does cubic mean? The cubic and cubic trinomial, what does it mean? Huh? to the it means that the biggest exponent is that 3. But the word that describes the number of terms is trinomial because there's 3 terms. Okay, so far so good. All right. That's number 5, subtracting polynomials. Find the difference. I tried to stress this to you. Sadly, I just, sometimes my efforts are fruitless because you guys want to do this stuff in your head. That's fine, but you do so at your own risk. Even though you think of it as being a wasted step, I strongly advise you to dedicate a step to removing the parentheses. Especially in this case, you're less likely to get away with it on 5 than you would on number 6. Because when you have a negative outside of a parentheses, every term is going to change sign. Not just the 2x squared, but you have to know that the 3x becomes positive and the 2 becomes negative. Jake, question? Just doing info. Your hair used to be longer, huh? Yeah, the picture of that. Very long. Okay, now let's combine like terms. If you also want to do it in standard form, that would be fantastic. BJ, what are the first 2 terms I'm going to combine? Yeah, what's 5x squared minus 2x squared? 3x squared. Okay. Now 8x and 3x. Chase, what's 8x and 3x? Good. Plus 11x. And then Armando, what's 5 minus 2?
3.
Just like your birthday. Any questions? 6. Stepwise, structurally is identical. We're going to do the exact same steps. The only difference is that when we do the first step that we remove the parentheses, because both parentheses have a positive 1 in front, every term stays exactly the same. 2x squared plus 3x plus 5 plus a negative is a minus x squared plus 4x. And then the minus 7 stays the same. And then we combine like terms just like we did on the first one. Geo, what's 2x squared minus x squared? Okay, and 1x squared is just x squared. I'm going to write this x squared. Viviana. What's 3x and 4x? Viviana. What is 3x and 4x? 3x plus 4x is 7x. Yeah, make sure we don't put 7x squared. Xavier. What is positive 5 minus 7? Negative. Hip hop parade. Yes, no question, Okay, so let's try to make things a little clear here. Have you taken geometry before? No. But at the same time, you've now had 2 quizzes that have had problems in there. They were bonus problems at the time, but you've had problems that had a little bit to do with geometry. And I'm not too familiar with the middle school curriculum, but I mean, how many of you in here before you got here knew what the formula for area of a rectangle was? Or better yet, how many of you have never heard of area of a rectangle? That's the only geometry that comes in. You'd have to know that area of a rectangle is length times width. So if I want to know the area here, what would I do? What would you do? Multiply, thank you. What are we going to multiply? Those 2 polynomials. And that you should definitely know how to do. So 2x plus 2 times 4x plus 3. We we would FOIL just like the cool kids do. 8x squared is 2x times 4x. Natalie, what's 2x times 3? 6x. Nate the Great, what is 2 times 4x?
2 times 4x. 8x.
That would be 8x. And Ansley, you got the easy one. 2 times 3.
6.
Good. So Ansley, I'll give you the bonus question also. Am I done?
No.
Why not?
Because you have to combine the 6x plus 8x.
Fantastic. What is that?
12x.
Ooh.
I mean, wait. 13. Oh, sorry.
It's okay. 14x. Yes, sir.
I know the first one was like you have to say how many feet. So like you want to solve a variable. So like if it said like it was like how many feet does she need?
Where? What do you mean the first one?
On like the first bonus question on like the first quiz, it didn't ask you for an expression. It asked
No. Let's be clear on this. There has not been one question on any test, on any assignment, on any quiz that has asked you to solve for a variable. There has not been one. You have not need to find that.
Like directly. It asks you for like how many feet.
Okay, so fine. So let's say that this was in feet. And I don't take away points for units, but let's say I already gave you the answer. Let's say that this was in feet. These are both in feet. When it comes to units, anytime you find an area, you just square the unit. It doesn't mean that you have to find the x. You would just say this is the area, and then the unit would be square feet. If it was inches, you would say square inches. But one thing has nothing to do with the other. The next unit is where we start solving for variables. What do you need in order to solve for a variable? Equal sign, yeah, that we don't have. Okay, number 8 here, if I can alleviate some concerns, you won't see anything with these types of markings here, because those I don't expect you to know. But look, I have helped a few people with this. There's been some kids coming in the morning and stuff, and the study guide was online, and they seem to know what it meant. I don't know if it was a common sense type thing, but they seem to know what it means. So these little slashes just mean congruent. So like over here we have a 6x minus 4, and then they put the 1 slash across from it. That means that this also is 6x minus 4. On the right we have a 12x plus 3 that has 2 slashes on it. That means that this is also 12x plus 3. Now see, this question asks us for perimeter. Perimeter is not an area. If you want an oversimplification of things, if area is inside, perimeter is outside. In area we multiply, in perimeter we add. Oh wait, but mister, you forgot the 14x plus 13. Well, no I didn't, because if we're going to go on the outside, I only have one of those, not 2. Even though they have the other little segment drawn, that's not part of the outside. So Princeton, if I write everything out, I would get 6x minus 4 plus another 6x minus 4 plus 12x plus 3. Actually, no, here, let's do this even better. Yeah. I think I have higher expectations of you guys now. So how many 6x minus 4s do we have? 2. So I'm going to write 2 times. Let's throw a little multiplication in there anyways. There's 2 of those plus how many 12x plus 3s do I have? 2. So 2 times 12x plus 3, and then at the end plus the lonely 14x plus 13. So if you were to write it this way, Princeton, what would I do first? Huh? Good. Distribute. Good. Remove the parentheses. 12x plus 8 plus 24x plus 6 plus 14x plus 13. So Princeton, I know you're sitting far away, but if you can see that, how many x's do I, because now I'm going to combine, how many x's do I have in total? What is 12x plus 24x plus 14x? How many? Good, 50x's. And then Kaylee, I'll let you finish it off with the constants.
I was just saying the 8 supposed to be negative.
You're right, thank you. Thank you. The x is supposed to be negative. Thank you. Okay, so then Kaylee, what is negative 8 plus 6 plus 13? What is negative 8 plus 6 plus 13? Go ahead, David. It is positive 11. Any questions on that first page? Okay, so let's keep the party going. Next page. Oh, look, wow, this looks exactly like what we just finished doing. So, Addie, what's my first step? Yeah, and what am I going to, Addie, what am I going to distribute to the first parentheses? 4. 4, good, that gives me 4x minus 4. And then, Addie, what am I going to distribute to the second parentheses?
-3.
Good, negative 3. So, minus 3x minus 6. Question, BJ?
No.
Okay. Zach, what is 4x minus 3x? Well played, Zach. And then negative 4 minus 6? Ah! Negative and negative. If you add 2 negatives, it stays negative. Go ahead, Ryan. Well played. Negative 10. Joseph, come back. Any questions here? Okay. Number 10. I was working with somebody this morning that was a little bit confused by number 10. I don't know if you should be too confused. There's something called function notation. You'll be introduced to this a couple units from now. I think it's before fall break, but it's a couple units from now. The thing is, we're not doing too much with function notation. That shouldn't throw you off. Just consider this as a conditional statement. It's an if and then. They start you off with an if. So if you don't want to think of Rx and Tx, just think of them like names. So like if Ryan is 2x plus 3 and Tammy is 6 plus 6x squared minus 4, then multiply Ryan with Tammy. They're just asking you to multiply. Just being asked to multiply. Like it's pronounced R of x and T of x, or it can also be pronounced at R at x and T at x. But just think of those as names. So they want us to multiply 2x squared plus 3 times. Before I write the other ones, do you see something I can do with that polynomial before I write it? I have a feeling that was a typo also, but with that one was fine. We can just play it as is. Do you see something that can be done there? Blake?
You have to subtract 6 by 4.
Okay, we got like terms, and then the other thing is that it could benefit you to write it in standard form. So the 6x squared is nothing like it, so 6x squared stays the same. 6 minus 4 is plus 2. Yeah, definitely. That's an ugly looking parentheses. So. And then we aluminum foil. 2x squared times 6x squared. Nikki? 2x squared times 6x squared. Good. Sinatra. 2x squared times 2. Yeah. Ethan, 2x squared times 2? 4x squared. Eric, 3 times 6x squared. What? 3 times 6x squared. Yeah. Ruth, 3 times 2. Thanks, Ruth. Wakey, wakey. And Lisa's here, my resident expert on like terms. Do we see any?
Yes.
Where?
4x squared plus 18x squared.
Okay, so here we go. Time to redeem yourself.
Okay. So 22.
Good.
I didn't want to say it wrong.
Nah, don't be afraid. One big happy family here. There you go. Very good. Robbie, I'm gonna let you start this one off. Okay. Product means multiply. So the good news, if anything, the good news here is that one of these two is just one term. So I actually want to write the 6x squared in front. And even though I'm not being told explicitly to do so, I think it would be in your benefit to write that other one in standard form. So Robert, can you write this first polynomial for me in standard form? Well, close. No, not multiplying yet. I just want you to write this for me in standard form. You want to ask Chase for help? Who wants to ask a Chase?
Negative 5x.
Negative 5x squared. Good. And then the rest of the Chase, go ahead.
4 plus 4x.
Good.
Plus 3.
Good. All right, Robert, now back to you again. Now let's multiply. Well, it is negative 30, but it's not going to be x squared. Sorry, that was a second.
Oh,
Good. Negative 30x to the 4th. And then? Plus 24. X to the 3rd, fantastic. Never thought I'd accuse Ashley of being too quiet, but it's the first time for everything. Ashley, number 12. Multiply x plus 5 times x minus 5.
What?
I want you to do the next one, number 12. You're awfully quiet over there. Are there any other questions on 11? Okay. X plus 5 times x minus 5.
I'm writing down the answer.
If you're clever, this should be a 3-second problem. Like literal, not figuratively, but like literally 3 seconds. Go ahead, Nate.
You want like all the steps?
There shouldn't be. There could be all the steps, but there shouldn't be all the steps. If you really know what's going on. Joseph, you woke up in time. Go ahead.
It just cancels.
No, say it better.
Oh, yeah.
Say it better. Come on, I'm looking for magic words here. Somebody show me you've learned something. You want David? Why though? Explain it to me. No, you did it the wrong way. Yes, Elena. If you want to FOIL, you can. I'm not telling you you're wrong. Go ahead and FOIL your heart out. X squared minus 5x plus 5x minus 25. combine like terms, it's fine. I'm not going to mark it wrong. But I would really love if somebody that picked up something along the way throughout this unit that can make this much, much quicker. Yeah, Nate.
I mean, I have the answer, but I don't know what you mean by something that would make it quicker.
Yeah, well, that's what I'm looking for.
Because if you said you didn't want.
Yes, Hayden.
There is 2 5s and 2 X's.
What do we call that?
That is.
I'll give you a clue. It starts with C and ends with conjugates.
Conjugate.
Very good. Those are conjugates of each other. Because it's x plus 5 and x minus 5. So what's the shortcut? Now, yes, I will admit that we've used conjugates primarily when it comes to radicals, but the same rules still apply. When you multiply conjugates, what is the result? Starts with difference, ends with squares, and has an of in the middle. Difference of squares. Difference means minus, square means what you think it means, x squared and 5 squared. I can't do anything with x squared, but what is 5 squared? But wait, I got the same answer, but I did it a different way. Fine. This means that you followed, that's fine. I'm not telling you that you're wrong. Just saying a quicker way. Okay. Let's do number 13, and then I want to try to do some radicals because we're already running out of time. This is going to be a pretty long one. What should I do here for number 13? How? Foil. On a 3x3 foil, how many terms should I get? 9. I should get 9 terms. Maurice, if you're doing like the box method here, that's fine too. If you're going to do this with a box, that's fine. So I should get negative 2x to the 4th. I'm going to take up some space on 14 because this is going to be long. I'm not going to get to 14 today. But it's the same thing. We're just multiplying. Plus 8x to the 3rd minus 14x squared minus 3x to the 3rd plus 12x squared. That's an x even though it's minus 21x. Then the 5 is going to be minus 5x squared plus 20x and then minus 35. Combine like terms. Negative 2x to the 4th just drops. The x to the 3rd, there's 2 of them. So it's positive 8 minus 3 is plus 5x to the 3rd. The x squares, there's 3 of them. Negative 14 and 12 is negative 2. Minus 5 is negative 7x squared. The x is negative 21 plus 20 is negative 1x, which is negative x. And then finally the negative 35 just drops. Here, this is the negative 21x. I got that from doing 3x times negative 7. Are there any questions on this one? I went a little fast. My goal today was to spend more time on polynomials because we hadn't seen that long enough. And you're like, oh, but look, you didn't go over any radicals. Well, it kind of did. When did we go over radicals? When we reviewed what? The quiz. Yeah, I'm not talking about it. I'm still going to do a couple radicals, but we did the quiz. When we went over the quiz on when? I don't know what day it is. On Tuesday. Hold on. Here, let's go to the page on radicals. Here, perfect. Let's do, yeah, I might be able to fit in. Let's do 16, 17, and 18. Let's see if we can squeeze these all in. On 16, what are we doing? 16, we're adding. In order to add, the radicals have to be the same. They're not the same, so I need a tree. 27 is 3 3s. 12 is a 2, and a 3. So in each of these cases, a 3 gets left behind. So I have a negative 3 that was already on the outside times a 3 I brought out is negative 9. I keep the square root of 3. On the next one, I brought a 2 out. There was a 3 there already, so that becomes a 6. square root of 3. Now I can add them. What is negative 9 plus 6? Yeah, so I end up with negative 3 square root of 3. For 17, all I got to do here is a tree with 108. So 254, 227, and then 3 more 3s. So I can bring out a 2 and a 3 to join a 4. What's 4 times 2 times 3? 4 times 2 times 3 is 24. Keep the square root of 3. On the last one, you saw a couple divisions on the quiz. If I could divide 10 by 3, I would, but I can't. So just rationalize. Square root of 3, square root of 3. That gives me square root of 30 over a regular 3. Then you would try to simplify the 30, but that doesn't give you any pairs. So ta-da, we're done. But wait, can't you divide 30 by 3? Why not? Yeah, one's inside, one's outside.